Assalamu alaikum friends, my name is Bilal Khan and this is my 9th video of DevOps. So this video will be starting from a transport layer. So in the previous video I have shown you what is the role of the application layer. Now let's move to the transport layer. So let's say you have a computer and that computer is transferring the data to your friend's computer. Alright, so the data will be transferred from your computer to your friend's computer with the help of network layer. Alright, so now the question arises that if the data is transferred using the network layer, then what is the role of the transport layer? So the transport layer will take the data from the network layer that is reached at the starting point of the friend's computer, and it will take this data from the network layer and give to the application. Alright, so let's say the data will be transferred from your computer to your friend's computer. Now it is reached at this destination. Now it will give that data to the transport layer that is present inside the device. So the transport layer is present inside the device. So the network layer will give the data to the transport layer, and that transport layer will give the data to the application. Alright, so let's look at the explanation. So the transportation or communication of data between two devices is done by network layer. Alright, so between two devices the data will be transferred through application layer. After that the transport layer lies inside the devices. Alright, so it will be inside the device. The role of the transport layer is to take the information from the network layer. Alright, so it will take the information from here and transfer it into the application. Alright, so it is in between the network and the application. So let's take another example, that here is a box that you want to send to your friend. Alright, so you will go to the courier company in your country. Alright, so that courier company will transfer your box to the courier company of another country. Alright, and that in that country your friend is present. So after that the courier company of this country will transfer the box to your friend's home. Alright, so the data, the box that is transferred from your home to the courier company will be through the help of transport layer. Similarly, the courier company of another country that is transferring the box from its courier company to the friend's home will be with the help of transport layer. But the courier company that is transferring the box from this country to another country will be with the help of network layer. Alright, so now let's move to another slide, and this is showing me that the transport layer is located in devices. I have shown you that the transport layer will be inside the device that will take the data from the network layer and give to the application. So now let's move to the multiplexing and demultiplexing. So multiplexing is a method or a technique in which more than one signals are combined into one signal. Alright, so this is a collection, these are the collection of signals that will be combined to form a single signal that will travel on a medium. Alright, so demultiplexing is the reverse of multiplexing. So instead of combining all the signal at one, so it will divide the one signal into multiple signals. So in which a multiplexed signal is decomposed into individual signals. So all the signals that are combined will be divided, and they will be reached at the individual application. Alright, so now let's take an example that here are three applications through which you are transferring the data. The first one is the messenger through which you are trying to send a message. The second one is the email through which you are sending a file. The second one is the video conferencing and the data is sent through a Zoom application. Alright, so these are three types of application, and the data will be received at the destination applications. So, alright, so here are the application messenger also present, the email is also present, and the Zoom application is also present at the destination. So now the transport layer multiplexer will come. Alright, so it will take the message, file and video conferencing data and combine it at one signal, in one signal. Alright, so that one signal will go to the transport layer demultiplexer. Alright, so after that the demultiplexer will assign each of the data to its application. Alright, so the message data will go to the messaging application. Similarly, the file data will go through the email, and the video conferencing data will go to the Zoom application. So how it will identify that which application, which data is belonging to which application? So it will be with the help of sockets. Alright, so I have shown you in the previous video that socket is working as a gateway between two devices, between two applications that will communicate with each other. So the sockets will be given a port number. That port number will identify the application. Alright, so in the sender side, on the sender side, the socket will be given a port number that will identify that this message is sent from a messenger, and the file is sent from email, and the video conferencing data is sent from the Zoom application. So when it is received, it will also be identified that if it is received, now the data will, the socket or the port number will identify the messenger, the email, and the Zoom application. So the socket will also go to the destination. Alright. So now let's move to the another slide, and the transport layer will attach port numbers to the sockets. Alright, to identify applications. Alright. So the transport layer takes care of the congestion control. It means to align the packets traffic one by one. So let's take an example of the cars that are present on the road. So let's say there are a bunch of cars that are present on a single road. So in this way the congestion will happen, and the traffic will be jammed because there are a lot of cars on a single road. So in this way the traffic police will come, and he will align all the cars one by one to pass. Alright, so in this way the transport layer is working as a traffic police. So it will align the packets that are mixed up together to be transferred one by one. Alright, so congestion control algorithms are built in TCP. So this is a type of algorithm that is of congestion control, and that algorithms are built in TCP. Alright, so now let's move to another question, that what if the packets get corrupted or it is transferred in imperfect order? Alright, so there will be a situation where the data will be corrupted in between when you are sending the data, or it will be in imperfect order. Let's say you send the data Bilal Khan, so the imperfection will be like Khan Bilal. Alright, so the data is not in perfect order. So how to deal with this situation? So the solution for this is checksums. Alright, so it is like a number. So what will this checksum do? So you have a computer, and you are sending the data to your friend. Now the checksums will be present in your computer, and this checksum is like a number that will perform some mathematical calculation, and that mathematical calculation will be equal to the data. Alright, so the data that you have sent will be equal to the mathematical calculation of the checksums. Alright, so similarly, your friend has received this data. Now the mathematical calculation will also be happen on the friend side. So it will also identify this data. Now if both the checksums or both the mathematical calculations number are equal, then it will be assured that the data is not corrupted. Alright, so if it is not equal to each other, then it will understand that the data is corrupted in between. Alright, so now let's move to another slide, and now the question arises that how the sender will know that whether the packets are received or not. Alright, so this is also a problem that you will have to deal with, that how you will know that the packets are whether received or not. So the solution for this is the timers. Alright, so let's say you are sending data to your friend. So you send a data packet to your friend, and the timer will start. Alright, so the timer will start, and the friend will give you the response that I got your packet. After that the packet will end. The timer will end, sorry. So the timer will end because the packet is received. After that, you will again send the packet to your friend, another packet, and in this way the timer will start again, but the packet is not received to your friend. So it is your friend is waiting for the next packet, but it is not received at your friend's computer. So after that, the timer has some kind of limitation, so it will expire after some time. All right. So the data packets is not received, so it will expire after some time. So let's take another example in which the data will be received to your friend, but the response will not be received. So how it will take, let's take this in another scenario. So you have a computer and that you are trying to send the data to your friend, and let's say you send a first packet, alright. So after that, the timer will start. So your friend will give you the response that I got this packet. After that, the timer will end. Alright. Now you send another packet. Alright. That packet will be the second packet, and it is received at your friend's computer. Now your friend will give you the response. Alright. So the timer will start at this second packet, and the friend will give you the response that I got it. But it is in between this responses get corrupted. So you are not receiving this message that your friend have gotten the packet. So in this way, the timer will start, continue, and after that, after some time, the timer will expire because it is waiting for the response to be given to you, but it has not reached to you. So the response will be, the timer will expire, and after that, you will send another packet to the friend. So in this way, this is a second packet also, because you didn't receive a message from your friend, so you are guessing that maybe this packet is not reached. So you send another request, and that is of packet 2. In this way, the duplication will happen because the packet is received to your friend, and both our packets are received, but the problem was that the response was not received to you. So in this way, both packets are present in your friend's computer. So in this way, the duplication will happen. All right. So it will check that let's say this packet is also present, and this second packet is also present. So which packet to take first? So to solve this problem, it will be assigned some sequence number. Alright, so the second packet will be assigned a sequence number 2. Similarly, this packet is also assigned a sequence number 2. So it will check that, we have received 2 packets that are of the same sequence number. So let's ignore one packet and accept just one packet. Alright, so after that, this is the scenario. Now let's move to the UDP, User Datagram Protocol. And in the previous video, I have also shown you that the UDP is not making sure to transfer the data 100%. Instead, it will transfer the data, but the data will not be reached 100%. Alright, so it is opposite than the TCP. So data may or may not be delivered. Alright, so some packets of data will be delivered, or some maybe may not be delivered. Data may change. Alright, this is the down case of UDP. Data may not be in order. It may be in imperfect order. Alright, it's a connectionless protocol. It means that the data will be transferred even if the connection is not established, because it is not caring about the data to be reached 100% at the destination. So it will not care. It will send the data before the connection is established. Alright, so it will send the data before any connection is established. So the UDP uses checksum. Alright, so it will check whether the data is transferred, but it does not care whether the data is transferred fully or not. So it will look into the data, but it will not does not care about the data, that whether it is transferred or fully or not. Alright, so now let's move to the UDP packet. So here are some of the things that the UDP packet contains: the source port number, destination port number, length of datagram, checksum, and data. So source port number, destination port number, length of datagram, checksum. So these are the things that are of 2 bytes. Alright, together they will form 8 bytes header. Alright, so after that, the total size of these data packet that the UDP packet contains, the one packet size would be 2 raised to the power of 16. Alright, so this is the total size of the UDP packet. So now the 8 bytes will be removed or subtracted from this 2 raised to the power of 16. Alright, so now the result would be 65,536 bytes. So this 65,536 bytes is the data that is present in one packet. Alright, so this is the size of the data that is present in one packet. So now let's move to the UDP use cases. So it is very fast because it is not caring about the data to be sent 100%. So it will ignore all the packets if it is received or not. And DNS also uses UDP. Alright, so in the previous video I have shown you what is DNS. So DNS also uses UDP. It is used in video conferencing apps and gaming. Alright, so in this video conferencing app and gaming, some packets may get lost. Alright, so now let's move to the TCP, that is the transmission control protocol. So it is used in transport layer protocol. Alright, so application layer sends lots of raw data. Alright, so TCP segments this data. Alright, so TCP will divide this data because the application layer sends a lot of data. So the TCP transmission control will divide this data or segments this data and divide it into chunks. Alright, and add headers. As the transport layer divides the data into segments, alright, the transport layer is dividing the data into segments, the network layer also divides the data. Alright, so in the previous, I have shown you that the network layer is transferring the data from one computer to another computer, and the transport layer is transferring the data from network layer to the application layer. So these are the communication of data. So all the data that will be transferred from your friend's computer to your computer through network layer, and from the network layer to the application layer, the data will be divided. So the transport layer divides the data into segments. The network layer also divides the data so that they can be put together at once when it is reached to the application layer. So it provides congestion control. I have shown you what is congestion control. It will align the traffic packets one by one. It takes care of when data does not arrive. Alright, so it will make sure to transfer the data 100%. So it will take care of that whether the data is arrive 100% or not. So it will maintain the order of data using sequence number. Alright, so the packets will be aligned one by one and the sequence number. Alright, after that, these are some of the features that the TCP has. So the TCP is connection oriented. It means that first the connection will be established and then it will send the data. Alright, in the UDP we have seen that it will not care whether the connection is established or not. It will send the packets. But the TCP is making sure to first establish the connection and then send the data. It provides error control. It will check the errors. Alright, it provides congestion control. We have seen TCP will make connection between two computers. Between only two computers, sender and the receiver. One connection will not be established with many computers. So the sender will not be connected with many receivers. Instead the data will only be transferred from sender to the receiver, not one sender to many receivers. Alright, so the data will be transferred only from one sender to one receiver. It uses full duplex to send and receive the data simultaneously. Alright, so the sending and the receiving process will be simultaneously at once. Alright, so let's say you send the data to from A computer to B, and the B computer will also give you the response at once. Alright, so the data will be transferred one by one at the same time. After that, now the question arises that how the connection gets established. So the connection is established using 3 ways handshake. The client will send a request to the server. This is the first handshake. After that, the server will respond to the client. This is the second handshake. Now the client will again acknowledge that connection with the server. This is the 3 handshake. So now here is the client and the server. So the client will send a request to the server, alright, with some synchronization, with a synchronization flag and a sequence number. So the synchronization flag is making sure that the connection is established from the client to the server, alright. Now after that, a sequence number will be assigned to the packets that are transferring from the client to the server, alright. So the sequence number will be in random. So now the question arises that why the sequence number is random? Because if it is aligned one by one, if it is given one by one, then it is possible to guess this sequence number, and a hacker could easily guess this sequence number and get access to the server. So to avoid this situation, the sequence number is set randomly. Alright. So after that, the server will give the response to the client, alright, with the synchronization flag. Because the client is sending a request to the server with a synchronization flag, that will make sure that the connection is established. Now the server is also making sure that the connection is established with the client. So it will also use the synchronization flag. After that, the acknowledgement flag will also be given. So the acknowledgement will make sure that will show the client a message that the client is connected to the server. So it is acknowledging that the server is connected with the client. After that, the sequence number is used. So the sequence number now the sequence number will be equal to 32 with some math on it. Alright. So there will be some mathematical calculation on this 32, on this previous sequence number, and the resultant will be the new sequence number. Alright. So let's say the result is 56. So now it is the new sequence number that is attached to this response. Alright. So the acknowledgement number is also given. So the acknowledgement number is equal to the previous sequence number plus 1. So in this case it is 33. So now the client will again send the request. In this way, this time the acknowledgement acknowledgement flag will be given to the server. Now the synchronization is not given because on both sides the connection are established. So now only the acknowledgement flag will be given, that it will tell the server that the response that you have sent is received to the client. So it is acknowledging that. After that, the sequence number, it is randomly created, 45 let's say, and the acknowledgement number. The acknowledgement number is equal to the previous sequence number plus 1. So the previous sequence number this time is 56. So it will be 56 plus 1, 57. Alright. So in this way the connection will establish through 3 ways handshake. After that, what we have learned today, transport layer, multiplexer and demultiplexer. After that, checksums and timers, UDP, UDP packets and UDP use cases. After that, TCP features and how the connections are built. So that's it. I hope you like this video. So if you like this video, then make sure to subscribe to my channel, and if you have any questions, then ask those questions in the comment section below. I'll be happy to answer all of them. So till then, goodbye.